Welcome to today's live demo. It is my pleasure to introduce today's speaker, Owen Garrett, Head of Community and Products here at Deepfence. With that, Owen, over to you.
Michelle, thank you. Hello, folks. Thank you very much for joining today's session, where I'll be really excited to share with you some of the new capabilities we've added to the ThreatMapper open source project. I'll talk a little bit about what ThreatMapper is to give you by way of background, because I know that some of the people, or I'm sure some of the people who've joined this session may be curious as to what the big picture for ThreatMapper might be. And then we'll spend some time going through 3 new capabilities that we added in the 1.3 release. As Michelle mentioned, I'm really happy to take questions. Please submit them through Zoom and we'll review any that come up at the end of the webinar and do our best to answer them. Or grab your details and we'll follow up offline. Let's begin with a little backgrounder. Why ThreatMapper? What is the point of this open source project? We're all critically aware of the importance of building secure applications, and in particular, securing or checking the dependencies that we use in order to create these applications, the third-party modules and components that go into modern cloud-native applications. And this initiative is known within the industry as the Shift Left Security Initiative. It puts the responsibility and the burden on the development team, on the DevOps team, to make sure that the code that they build and ship to production is as secure as possible with no known vulnerabilities. The Shift Left process, I wager, is, and in quotes, is easy. It's easy, I say, not because it's straightforward, but because there's a lot of support to help organizations shift left and scan their code and check for vulnerable dependencies. As the code is built, it goes through the CI pipeline and it finds its way into the repository or registry and then gets deployed to production. There are third-party and integrated tools and components, things like SNCC, open source, at least for certain limits of usage. Platforms such as GitHub and GitLab have scanning tools, and there are commercial tools from Qualys or WhiteSource and the like. All of which insert themselves into the DevOps process and provide a gate to ensure that any dependencies in the supply chain for the application that's being built are scanned, and any issues are flagged up for the attention of the developer or the DevOps team. And together, these shift left initiatives try to achieve the dream that the developer can say, I'm confident that the code that I have written and the applications that I have built and which I push to production, I'm confident that that is free from known vulnerabilities. This is a really important part in the process of building and managing secure applications. But the unfortunate truth is that it's not the full solution. It is a dream, but the reality is somewhat different. The reality is different because securing right is a complex, messy, unpredictable process. The code that your developers build and put into their registry is not necessarily the code that gets pushed into production. The registry will be extended with third-party container images and apps that didn't go through your shift left process. As your application is pushed into production, it may be augmented through the injection of sidecars for things like service meshes and other agents and integrations that are automatically added to extend the application. And of course, this application runs on infrastructure that itself needs to be secured. Application servers and host infrastructure that doesn't go through the shift left scanning process, instead is sourced from third parties. So first of all, what you push into and operate in production is not necessarily identical to what you built and believed was secure. Furthermore, exceptions have to be made. When a developer builds a piece of code and bundles dependencies, some of those dependencies may have currently known vulnerabilities. And patching those vulnerabilities may be impractical. It may delay the deployment of the application, or the developer may make a judgment that those vulnerabilities are not significant. They are outside the attack path. And so exceptions are made. Code is pushed into a repository and on to production with known vulnerabilities. But finally, and perhaps most importantly, vulnerabilities can be disclosed at any point. And code which is believed to be free from vulnerability at time of build and creation of the gold image may be pushed into production only for vulnerabilities to be revealed or disclosed after it's running in production. And so the reality is that despite the best efforts of developer-centric shift-left processes, production without additional management can get out of control. And the AppSec team responsible for the production environments will acknowledge that they know there are vulnerabilities in the production services and components, whether they were deliberate and conscious exceptions, whether they come from third-party components that were not subject to shift left, or whether they were late-breaking vulnerabilities that were unknown when the scanning happened. And so the question that faces the production team is, knowing or being certain that vulnerabilities exist, how can one find them? And having found them, are these vulnerabilities a risk to the production application and therefore something that needs to be remediated as a matter of priority? This challenge, the challenge of secure right, is the challenge that Deepfence's ThreatMapper open source project addresses. ThreatMapper is an open source platform that runs against your production environments and does three core things. And we'll see these things as we go through the demo in a couple of minutes. It learns the topology, what's running in your environment, it scans it for vulnerabilities, and then from the vulnerabilities and topology, it calculates potential attack paths for the vulnerabilities within the application. The topology view in ThreatMapper gives you a rich GUI-based tool to explore your production infrastructure, to discover the workloads and containers that are running, the network connections that they're processing, the resources that they're using, and to initiate scans against those individual workloads and hosts. From the topology view, having initiated a scan, you can then review the scan results. You can look at the vulnerabilities that were discovered against individual workloads and entities within your production environment, against containers and hosts. You can drill in, you can filter those, you can look at the bill of materials that was generated against each of the scanned workloads. And finally, with ThreatMapper, you can then put this information together to understand, of the several thousand theoretical vulnerabilities that were discovered in your production environment, which of those several thousand are of critical importance? Which are the top 3 or 4 vulnerabilities that pose the greatest risk, that can be exploited by an attacker through remote network access, and are running on workloads or hosts that routinely receive traffic from the attack surface? This most exploitable vulnerabilities calculation then tells you which of those vulnerabilities you need to fix first in order to improve and optimize the security of your production platform and the applications that are running within. ThreatMapper is a capable open source project. It was released about almost 6 months ago. It's been used, that we've seen over 500,000 pulls from Docker Hub for the ThreatMapper container. We've seen almost, what's the count now? I forget, a large number of GitHub stars and continuing to grow. So approaching 1,500, I believe. And we're continuing to innovate, adding new capabilities into ThreatMapper. The most recent release, 1.3, was issued a couple of weeks ago, and it brings 3 new capabilities to the ThreatMapper platform. First of all, it brings into the fold our Secret Scanner project. Secret Scanner is a useful tool that scans runtime and registry-based workloads, looking through the file system to see, are there potentially exposed secrets within those workloads? Secrets that an attacker may be able to access and then use in order to spread laterally or gain control of your infrastructure. ThreatMapper 1.3 refocuses our vulnerability scanning around the generation of SBOMs, software bills of materials. So first and foremost, ThreatMapper can generate an SBOM from the running applications or registry-based applications, and then use that SBOM as the source for its vulnerability scans. And finally, the most distinctive and useful capability within ThreatMapper is its attack path calculation, telling you how the vulnerabilities that were discovered can then be exploited by a determined attacker. And we built this capability out and will continue to innovate and extend our attack path visualization and calculation to help you understand which of the vulnerabilities you need to fix first in order to minimize your exposure to risk. So let's see this running in action. Let's have a look at the ThreatMapper Management Console. It's monitoring a number of production systems, and we'll explore and focus in particular on these 3 capabilities. Here is the ThreatMapper Management Console, and we're looking at a multi-cloud environment. We have workloads running within DigitalOcean. Here we have a Kubernetes cluster with a number of containers running inside that cluster. We have a single host running Docker with a number of containers and applications on that host. As well as DigitalOcean, we can look at the workloads in AWS. So on US East, a host running a small container. And on Google Cloud, again, another service running in US East with additional hosts running other applications. All of this information is automatically discovered by Deepfence ThreatMapper through a client-server architecture where lightweight sensors are deployed in the production environments, and they discover the running workloads, the network traffic between those workloads, and feed that information back in real time to the management console so that it can build this dynamic graph or chart of what is running within your production infrastructure. The chart, of course, can become a little bit unwieldy when you have a large and complex environment. So if we drill that down and take out, we can look at our view of what's running from a cloud-centric view. So our Google Cloud, our AWS Cloud, our DigitalOcean Cloud. We can look at a Kubernetes-centric view. So let's just look at the Kubernetes clusters, the nodes and the workloads in those clusters. Or we can, if I move that out of the way, we can take a host view, looking at the servers that are hosting our infrastructure. These are typically cloud-based servers, but could as easily be on-premise servers, either running applications directly, running Docker, running Kubernetes. Although we don't have it in this particular demo system, we can also monitor Fargate serverless instances and look at the workloads running on AWS Fargate. Should this visualization be a little bit complex or unwieldy to use, if you wish, you can also take a table-only view. And we can start with individual clouds, look at the workloads within those clouds and the status of each of those, identifying a particular workload. So here is a host, the log4j POC host, and we can initiate a vulnerability scan against that. So let's run everything against there and kick off a scan against that host. And we can also initiate a secret scan. So 2 scans now against the log4j POC host are queued by ThreatMapper. All of the information which you see in this topology graph or table is also available through a series of ThreatMapper APIs. So you can automatically use the APIs to discover the workloads that are running, pull out metadata about those workloads, and trigger scans against some or all of those workloads. Once the scans complete, they're available in our vulnerabilities and secret scan reports. I mentioned that one of the new capabilities that we added to Deepfence ThreatMapper was the ability to scan running workloads and indeed registry-based workloads, looking through the file system for potentially unprotected secrets. Secrets are things like API tokens, passwords in the clear, and other kind of things like keys, SSH or SSL, TLS keys. Many secrets are present for good reason. They're needed by the server, by the workload in order to operate correctly. But there is a risk that secrets will find their way into production from the development system, and the secrets present on running workloads may give that workload greater privileges or access than it needs. So the purpose of the secret scanning within ThreatMapper is to provide you with a way to scan and then audit potential secrets found within running workloads and identify the 1 or 2% of those secrets that maybe slipped through by mistake and needs to be removed. Let's look at some of the recent secret scans. We've got a number of containers and hosts that we triggered scans against, and the data's popping up here. Let's say we're just interested in what we believe are high significance secrets. So let's look at the WordPress container. It's picked up 1 high priority secret. There's also a number of medium and low. So here we have on our WordPress container, in our scan, we found a secret username and password in our URI. The secret scanning functions by running a number of tests against file names, file extensions, and file contents on the running host. The Deepfence sensor audits the container, creates a tar file, if you like, of the container file systems, passes it back to the management console, where it's then scanned using a powerful regex engine built on Intel HyperKit. Here we have a rule. The rule, username and password, searches the contents of a file using this regex in order to match. And in this case, it pulled out on this particular file name here. It matched a certain piece of content. And indeed, here we can see we have a URI and we have an embedded regular expression. Sorry, we have an embedded username and password inside that URI. In this case, we look at the file. It comes from Perl distribution, tiny.pm, and it's most like, in fact, we can see it's part of the documentation. If you were to inspect that file, you'd see exactly what's going on. So in that case, we'll probably feel happy to allow that through. So we'll take that particular one and we can select it and we can decide we want to mask it. So we won't see that again. That then removes that rule, sorry, that result, because we've decided we're happy to allow list it. Let's go back and look at some of the other secret results. So let's find something else. Let's try a host. Here's a scan. Again, we found a number of potential secrets on that host. We find a number of things pulled up by a WordPress rule. So if we look at that rule there and just picking one of these things at more or less at random, we have a rule here, expanding that out, wp-config, that is looking for files that contain content that define common WordPress rules. And we've picked up wp-config sample.php. Once again, probably something safe, so you may choose to mask that. But as I've looked through here, in other cases, we find examples of the initialization scripts for WordPress that were inadvertently left in place. Those are things that you may well wish to address. The secret scanning can pull out things such as private keys. Here we find an SSH key, and we can look the rule that is looked for, elliptic curve or other types of private keys. Once again, this is something that you may wish to look into to verify that this particular workload only has the private keys it ought to. And it may give you pause to thought to then think about the PKI infrastructure that you use to ensure that a workload cannot take, or an attacker cannot use the access to these private keys in order to spread laterally within your infrastructure. So secret scanning is a fantastic, useful capability to identify, to find potentially compromisable secrets within your infrastructure that an attacker may be able to use in order to spread laterally if they manage to first establish a beachhead or otherwise gain access to the workloads that are hosting those secrets. And as you saw, secret scanning is initiated by picking individual workloads and then, oh, let's go back to the graph, and then triggering the secret scan against those workloads. So we grab the management, the agent there, and we can trigger a secret scan as so against that particular host in this case. The second significant capability that we added to ThreatMapper in this release is to refactor some of the ways that we do vulnerability scanning in order to create an intermediate SBOM or software bill of materials. The software bill of materials has emerged as being a very, very significant way that an organization can accurately identify what is running within their production infrastructure. Many of the shift left tools that we talked about previously can generate software bill of materials from applications as they go through the CI pipeline. But those SBOMs have limitations. They don't always accurately reflect what's running within your production environment. As we saw, your production environment can be extended. When an application is pushed into production, it could automatically have agents or integrations added to that application. Sidecars could be injected. Modifications could be made to the application as part of the deployment process. The SBOMs that you generate as part of your CI process will not give you consistent coverage of everything that's running within your production environment. Anything that didn't go through your CI pipeline will not be scanned and an SBOM won't be generated. And finally, and this is a work in progress within the ThreatMapper project, there's a lot of information you can add to an SBOM based on the runtime metadata that you can identify from the application as it's going. So here, for example, we can look at our log4j POC host, and we can see the SBOM, the list of packages. We can annotate that with the CVEs that may match those particular packages and their vulnerability status. ThreatMapper sees other runtime information, and in due course, we'll be extending the SBOMs that we generate, decorating them with more and more runtime information to create more and more useful data around the services that are running. You can go to an individual vulnerability scan. So here we have a list of the scans that were made, and you can take a scan. Here's one that was run recently, and we can, after seeing the list of CVEs, we can also pull the SBOM So we can click on there, download it as a JSON file. In time, we'll also support standard formats such as CycloneDX and SPDX, but we'll use JSON as our standard lingua franca, our base point, because that gives us the ability to then extend it with additional metadata. You can pull those SBOMs through the UI, as so, or if you wish, you can pull them through the API, giving you a way to then enumerate your infrastructure, identify the hosts and workloads, and pull SBOMs from each of those. So if you wish to do offline scanning, you can then perform that scanning against the SBOMs that ThreatMapper has generated for you. Finally, having discovered workloads, generated SBOMs, run vulnerability scans against those SBOMs to identify critical and other vulnerabilities in those workloads, ThreatMapper then puts all of the information together in order to give you a visualization of the most exploitable vulnerabilities. These are the vulnerabilities that should be at the top of your list as needing remediation. They are vulnerabilities of a high severity or which are network exploitable. They're vulnerabilities in some cases that are receiving live connections. Right now, ThreatMapper has detected active connections to those vulnerable components, or they may be running on components which ThreatMapper has seen historical connections. And ThreatMapper visualizes these using the concept of an attack path. Here we have the most vulnerable attack paths. So particular workloads, exposing CVEs and exposing open ports so they are network accessible. Some of these vulnerabilities may be chained. So we may say indirect exposure. So here we have traffic going through an Nginx instance to a WordPress instance to a MySQL instance, all of which are exposing CVEs. So with this information managed in real time, you can then determine which of these vulnerabilities you need to feed back to your team through the various integrations you can generate. So we can take a quick look. You can push this information out to Slack or PagerDuty. You can generate reports. So PDF or Excel reports enumerating the workloads and the vulnerabilities within. ThreatMapper running against your production infrastructure will help you understand what are the steps that you need to take right now in order to most quickly improve the security of that infrastructure. It's a fast-moving, actively developed open source project. We have a lot more capabilities planned within our roadmap. Software vulnerabilities and secrets exposures are not the only risks that your application faces at runtime. We're bringing in capabilities to run compliance scans against your production infrastructure to make sure that the infrastructure is following best practice for system and infrastructure config. Is it following good practice from the CIS and from NIST for Linux hosts, for Docker hosts, for Kubernetes masters or nodes? We will take the compliance information along with vulnerabilities and secrets, and we'll continue to build out the attack path visualizations and other ways of understanding what are the most significant risks that your infrastructure faces, presenting those in asset and compute specific views, as well as focusing on vulnerabilities, secrets, and compliance issues, allowing you to understand the entire risk picture and make informed, educated decisions as to what needs to be addressed as a matter of priority in order to most quickly improve or optimize the security of your production environments. ThreatMapper centers around the task of learning what's running in your infrastructure, identifying vulnerabilities and compliance issues, and building a threat map, telling you what are the greatest risks your application faces. On top of ThreatMapper, the open source project, is our ThreatMapper Enterprise product, which builds on, Threat Striker Enterprise product, which builds on ThreatMapper by adding runtime telemetry and attack analysis to understand the behavior of attackers as they roam across your application. The technologies are out of band. They're extremely lightweight. They don't use proxies. They don't require kernel modules. They don't require application changes. And they support multiple different types of applications across multiple clouds at the same time. Bare metal, virtual machines, containers, Kubernetes, serverless with Fargate and Lambda in our roadmap. You saw some of those capabilities in the ThreatMapper demo just a moment ago. Spanning multiple clouds so that you have a single point of monitoring, of observability, to understand the risk that your applications face, and with Threat Striker, the attack behavior that is happening within your application platforms. ThreatMapper is an open source project, 100% open source. There are no feature limited capabilities. There are no limits on the size of the environment you can scan or the number of scans that you can do. Completely open source. And I'd love for you to take a look. You can pull it from GitHub. You can build it directly from source, or you can deploy it on Docker, on Kubernetes with the management console using our pre-built images, and deploy the sensors across your production environments. Find us in Slack. If you try it out and have questions, then we'd be delighted to do our best to help support you through our Slack channel. Or reach out through deepfence.io to schedule a demo of ThreatMapper and Threat Striker. Or look on our README, find the link to the sandbox, try it yourself, or as I explained, with a couple of commands, you can get ThreatMapper up and running. We'd love your support for the project. If you do use it, please connect with us through Slack. If you come across any problems, raise them as issues against the GitHub repo, and do star the project by way of acknowledgement that you've taken a look and it's something that you wish to follow in the future. We're very keen to continue to work with the community to shape this ThreatMapper platform to become a broad and comprehensive solution that complements your shift left initiatives and helps you secure right to scan your production environments for vulnerabilities, for secrets, and in the future for compliance issues, and to bring this together in a way that helps you build applications that are more secure and operate them in a way that's safer for your applications, for your business and your users. So thank you very much for your time. I hope you've been inspired to take a look at ThreatMapper, to try it out, do get in touch. And I'll bring this session to a close now. I'll take a brief pause. I'll hand back to Michelle and we'll review the chat and the Q&A and see if there's anything that we can address before we wrap.
Thanks, Owen, for showing us around ThreatMapper and all the new features. I've seen a couple chats here. They're mostly just comments on how promising the tool looks. But if anybody does have questions, just head on over to the Q&A tab at the bottom of your screen and let us know what question is on the top of your mind, and we will do our very best to answer.
Sure. So just as anyone's thinking about any questions they have, I'll kick off with a couple of questions that I commonly get whenever I talk to potential users of ThreatMapper. So one of the most common questions I get is that my development team is already using Red Hat and Claire. They're using SNCC, they're using GitHub for dependency scanning. What does ThreatMapper give me in addition to those particular tools, or should I look to replace those tools with ThreatMapper? And the answer is, first of all, no. We're not here to replace existing shift left tools. Using, whether it's Claire, whether it's GitHub or GitLab tools or others, that is a really important part of the health, the security, health, and hygiene that your development team will adopt. It's very, very appropriate that you use those tools to ensure that the applications that you build are as free from vulnerabilities as possible. But ThreatMapper addresses the 3 challenges that I mentioned earlier on within this session. In runtime, you don't fully know what's running. There are third-party components that may not have gone through the vulnerability scanning that your first-party components did. There were exceptions made, inevitably. We always see that some vulnerabilities just cannot practically be fixed before the application is pushed into production. And any security policy that says we have to eliminate every vulnerable component before we push an application into production, every policy is doomed to fail if that is the case, because it's not a practical, realistic challenge, requirement. And thirdly, and most importantly, is the late breaking vulnerabilities. It's the Log4j, it's the Apache struts, the other ones that make the headlines that then give you pause to think, was the application that I deployed last week or last month or last year, was that vulnerable to this? And if so, how can I find out? These are the things that ThreatMapper addresses, complementing your shift left initiatives and giving your AppSec and SecOps teams tools that allow them to scan workloads across multiple DevOps teams to find vulnerabilities and prioritize these. Someone's asked, does ThreatMapper provide equal visibility across all cloud service providers? Yes, and that's one of the great capabilities. One of the benefits of having a targeted open source tool that's not part of the suite of security tools that an individual cloud provider gets. We give you consistent visibility, whether you're looking to scan serverless environments, so Fargate running in AWS, whether you're scanning hosted Kubernetes on AWS, on Azure, on Google, or indeed elsewhere, whether you're scanning machines running Docker, bare metal machines, virtual machines, it's the same no matter which cloud provider you're using, or indeed if you're running on-premise. So ThreatMapper gives you a single pane of glass or single console that's consistent across all production environments. How can you get started with ThreatMapper? Find us on GitHub. Let's go back. Find us on GitHub. Deploy ThreatMapper. You can deploy it, the management console, in a Docker environment or in Kubernetes cluster, and then push out sensors for production environments, or get in touch through deepfence.io and we will schedule a demo. It will take no more than 15 minutes of your time. And if it proves to be promising and we can address the questions that you have specific to your infrastructure, then we'd love to work with you further to help you with a deployment of either ThreatMapper or ThreatStriker. So I think with no more questions or comments, we'll draw things to a close now. Michelle, thank you very much for hosting this today. Everyone who joined, thank you very much for your time. I hope this has been useful. Please check it out, give it a star, and find us in Slack. All the best, and thank you very much.